Hey, thank you for tuning in to another episode of In Range. We're once again joined by Nathan from Faxon. We wanted to have another part 4 on rifle barrels, and we still have a long list of questions of things we haven't addressed in parts 1, 2, and 3, and we probably won't address enough in this one, and we'll probably have 5, 6, 7, I don't know. It'll go on until we've answered all the questions, which will be in infinity. But it's been such a valuable series that there's no reason to not continue with it. And we also plan to have some future episodes about some other stuff, which is really interesting too, about pistols, but that's not today. So, Nathan, thank you for joining us. Obviously, we have Ian as well. And let's just get the ball rolling with the first question, if you don't mind.
That's great.
This one comes up a lot, and it's actually surprising to me that we didn't address it already. But people want to know, what's the difference in chamber cuts? Like, so for example, you have a 223 cut, you have 5.56 NATO, you have match, you have Wylde. What are all these things, and are they relevant, and why?
All right. So everybody brace yourself. We're going to kind of geek out just a little bit here as we get into...
Oh, no.
None of that. We don't like that on this channel.
All right, so the primary difference between the chambers is going to boil down to two things. One is going to be the free bore, which is defined as the space between the end of the case before the beginning of the lead. Basically, it's rifling free space. And then you also talk about the lead, which refers to the angle or the angle of attack of the rifling as it starts. So usually that's a really shallow degree, believe it or not, but it allows the bullet to jump into rifling and not just go from, free bore and free space directly into a 90-degree shoulder. That's what you're trying to do. That would rip up a jacket. So it allows that transition between the two. So in the case of 5.56 versus 223 Remington, it's important to understand that the 223 Remington was designed to be about a 55,000 PSI or so commercial cartridge. So it was designed with accuracy and speed in mind. So when that was created, what they wanted was a really short free bore and a really aggressive lead. So they wanted the bullet to jump from the cartridge into the rifling the minimal amount possible to maintain safe pressures in the chamber. Following so far?
Yeah, and that's a common thing when you're a reloader to get the most precision and accuracy out of your ammunition, is to reduce that jump from the cartridge for the bullet before it engages the lands and grooves. And so we even in high power land would even get to the point where some guys would jam it. They would actually not even crimp the bullet, and when they seat the round, the bullet seats against the lands and gets pushed into the case, and there's actually no jump. It's not a good idea, but some people did it for precision. Yeah, yep. I know. I'm not saying do that out there. I'm saying people do that. But that jump is sometimes one of those things that people try to reduce for accuracy.
Yep. So going into the military ammunition, the military's mindset was, one, I'm going to crank up the power because I want the quote-unquote stopping power. We can get into that argument later. But they also went with a long free bore and a long lead to ensure compatibility across military spec ammunition, which is not as tightly controlled in some cases as the 223 Remington. Combine that with NATO, so you've got the Belgian SS-109, you've got the French making their own ammo, you've got the Germans, everybody's making it, while in theory to the same spec, slightly different. So the idea was, I'm going to make a more open chamber so that I can handle stuff and I can handle that higher pressure easier. So basically what that means is, practically speaking, the round in a 5.56 NATO chamber is going to jump farther from the case before engaging the rifling, and it's a more gradual engagement with the rifling than your 223 Remington. And what that does is you're going to sacrifice a little bit of velocity, but you're also going to add a large safety factor in there for that immediate pressure spike inside the chamber. You're allowing that bullet to jump, which is giving the explosion just that little bit of extra space to be able to dissipate that pressure at that critical moment in the ignition sequence. So to answer your question on, say, what's the difference between 223 Wylde, which is what everyone hears for, man, that's the magical spec I got to have on a barrel because that's more accurate. That's kind of true. So What 223 Wylde does is it's maintaining the long free bore, but it's going with a more aggressive lead compared to 5.56. So you still have a reasonable jump to try and maintain that safety, but you're also in theory reducing that a little bit by increasing the aggressiveness of the lead. So the bullet's going to engage farther. It's going to obturate less, meaning it's going to yaw a little bit less before it engages the rifling, and therefore you get better accuracy. On the flip side, you also gain a little bit of a spike in pressure relative to 5.56 NATO, but not as substantial as the pressure spike as 5.56 NATO ammunition in a 223 Remington chamber. But the practical effect on accuracy for a standard combat barrel, for most barrels, to be perfectly honest, meh. The reason being is there's about 15 things that need to be done right before the type of chamber cut is even going to come into the equation as being that next little knob you need to twist to make the barrel that much more accurate. So I'd tell anybody, if you're buying an inexpensive barrel, and I mean really inexpensive with 223 Wylde chamber, you're not really going to see any benefit. You will see some of it when you start getting into your higher end, as people call match barrels. So that's going to be where you either have hand lap bores or you have specific quality control processes in place that are going to, check mark the first 10 things before you get into the chamber, and that's when you can see it have some benefit. So I'd tell somebody, if you're buying a general clinker, if you're just having a gun that's just going to go shoot, go with the NATO chamber. It's maximum compatibility, maximum safety, and only if you really know what you're trying to do, you're shooting match loads, etc., does you really need to look at a 223 Wylde chamber as being that, I need that spec versus I want that spec.
So to sum this up crudely, the 223 chamber is fairly tight. The 5.56 NATO chamber is pretty open and large. The Wylde chamber is somewhere between the two, and match chambers are exceedingly tight. I can tell you from my, again, precision experience trying to shoot long range, I was playing around with match grade or match chambers at one point, and frankly got fed up with it because the reloading requirements to make that reliable in a semi-automatic was intensive, and the reality was that I eventually gave up and just started going with 5.56 NATO chambers, which should be the least accurate, and the reality is that your reloading procedures and how you make your ammunition plays far more an important part in making accurate shots and precision groups than the chamber cut in and of itself. The chamber cut just helps. At least that's my experience. What do you think?
I think you're hitting the nail on the head from the reloading standpoint. On the actual barrel manufacturing standpoint, the consistency of the bore, the cut of the crown, the concentricity of the chamber, the definition of the rifling, all of those things are going to be far, far more important than the actual type of chamber cut. Because even before the type of chamber cut, how well is the chamber cut? If you've got a good 5.56 NATO chamber that's been hand polished, you are going to be likely to be far more accurate than just a rough ream 223 Wylde. So somebody really has to pay attention to what are they looking for in that barrel and going with a trusted name to be able to get the benefit of that change in specification.
Right. So what I was going with back then were the white oak barrels, which are were at least high end on the high power land. And so I found personally when I switched to a larger chamber cut, such as 5.56 NATO, I mitigated a lot of my reliability problems because I didn't have to deal with small base dies and all sorts of stuff like cartridges getting stuck or whatever, or keeping the thing meticulously clean. And but reloading the ammunition to the same level of OCD turned into the same accuracy, practically speaking, for my scores. I saw no difference in my groups. Now, could you have made those groups even better if you were a better shooter or Benchrest with a tighter chamber? Yeah, but as long as you have a quality barrel, in my opinion, the chamber cut, as long as it's big enough or forgiving enough for the reliability you're looking for, is usually just fine.
I think there's a common misunderstanding or a common expectation that this loose versus tight chamber has something to do with the radial dimension, the diameter of the main body of the cartridge, which it really doesn't. We're talking about the throat, right?
Yes, that's primarily what we're talking about. The radial dimensions of 223 and 5.56 from the shoulder on back are fundamentally exactly the same. So you're really only talking about the portion that's in front of the cartridge that the bullet is interfacing with.
Yeah.
And this also does play into if you want to start using exotic projectile types like 80 grains and stuff, because you, again, as I mentioned earlier, some people will jam those bullets against the lands and grooves in their cycling process, but that's not a good procedure generally speaking. So you want to make sure you have a little bit of that free bore or jump for safety reasons, because otherwise you can induce a high pressure problem.
Yep. I'd only tell you to load up to the lands if you know what you're doing and you know how your powders react under those circumstances. As far as Faxon is concerned, we always default to safety. That's why you see us doing 5.56 NATO, and you'll only see us do 2.23 Wylde when we feel like, hey, we've taken care of all of those objects or all of those items on the checklist, and you're actually going to see some benefit from the chamber itself.
And I would argue there's very little reason to jam like that in general, and people that are chasing that level of precision are really on this cutting, bleeding edge, and they kind of, for the most part, know what they're doing, because they wouldn't be trying to do that unless they were trying to squeeze that last ounce out of the gun. And for the most part, unless it's Benchrest, you don't even need to do that, but you get caught up in this game of, oh, I need that extra 0.001 of an inch of an MOA or whatever, which, generally speaking, isn't real, but it is what it is. Cool. Very interesting. Thanks. Let's go to the next question. What does it take to get to quote-unquote sub-MOA? And I think this is another similar question to what we just asked, but there's a lot of factors that play into this.
Okay. So compared to 25 years ago, we've always talked about modern manufacturing techniques, and that has come a long way in the last few decades in making great barrels, whether it's cold hammer forging guys knowing exactly what processes they need to go through, to us on the Faxon side, using button for mass manufacturing. It's actually quite easy, relatively speaking, to now get to that sub-minute of angle. There's a well-known website that says if you're a $1,000 gun or more, you should be shooting sub-minute of angle. Yeah, I'd say that's very much possible these days. And that just goes to having companies understanding, one, the actual performance of the round inside the bullet, understanding ballistics, and being able to create product using quality control techniques that were perfected from the auto industry and other industries in the firearm side, where firearms didn't necessarily have that level of quality control or process control that they did previously.
Aviation especially. A lot of gun companies are evolving out of aviation companies. And if you're in the aviation manufacturing field, if you don't know QC, you're gone.
That's exactly it. Faxon does aviation work. We're AS 9100 certified, in case anybody's ever curious what the certifications are. What that really is telling the outside world is, hey guys, we've gone through this QC process. We understand what QC needs to happen prior to making the part, while making the part, and after making the part, and then how to, and this is probably the most important part of it all, is if you have to make a change to the part of the QC processes, how to document that so you have contiguous production without having disruptions to the material and production flow.
Yep. Imagine that, considering the AR's history and its interrelationship with the aviation industry. I mean, it is what it is, right? Now, I would also argue that it's not just a barrel to get to sub-MOA. I mean, the gun design itself and your ammunition play an incredible factor into that. So we're going to anger some people here, or I will, and I'll take the heat. Putting on a very expensive, wonderful, perfect barrel on an M1A doesn't just get you sub-MOA because you put on a new barrel. However, putting a super-duper nice barrel on an AR derivative, for the most part, might get you there. So the gun design really plays a factor into that. And what would you want to add to that?
Yeah, you have other things outside of the barrel itself. You have modern manufacturing. Let's say Swiss turning is able to manufacture AR bolts that are consistent within tenths and sometimes millions of inches from part to part to part to part. That didn't exist when the AR-15 was originally created. You actually have tolerance stack in the chamber, the extension, and the bolt that could take a barrel out of headspace, and that was allowed when the AR-15 was originally and M16 was originally being produced. These days, I can tell you, manufacturers, we don't tolerate that. We've cut those tolerances down significantly because that's what we know gets the guns to work and gets them to work well.
I think things have changed a lot just in even 15, 20 years. I mean, an AR from 20 years ago on the commercial market versus an AR, or an AR from built today, even a cheap one, are very different than they were back 15 years ago because the manufacturing capabilities and qualities have changed dramatically too. But where I was also going with that is like when I said the M1A or an M1 Garand for that matter, what makes accuracy is consistency. And so, for example, that locking lug, the multiple locking lug bolt on an AR-15, even a low-end one for the most part, is likely to lock up with more consistency in the chamber than a dual rotating locking lug system like on an M1 or an M1 Garand, an M1A or an M1 Garand. And maybe you'd want to chime into that, Ian, but the gun's design plays into this. Like a tipping bolt, for example, is typically not a very accurate design. It might be reliable, but it's not going to generate high accuracy, generally speaking.
Yeah, everything has to go right to get sub-MOA, and any one of those factors that isn't, that you're going to have, your accuracy is determined by the weakest element in the entire system.
Mm-hmm.
So,
and I know you guys have had these similar chats with Mac over at Hill and Mac. And we know he's been talking about getting great results even out of a tipping bolt. And that just goes back to the same tolerances thing that we've been talking about. Tipping bolt may not be as accurate as multi-lug rotating bolt, but you can make them really good these days, especially with the consistency that modern machines provide.
Yeah, I guess the way to sum that up is a tipping bolt is harder to make lock up as consistently as an AR-15 star type bolt locking system. It's just harder to do. Is it possible? Probably. But it's a more difficult endeavor.
Yep. And we've been involved in projects where we're taking AK-47s to sub-minute of angle accuracy. You can do it. You can absolutely do it. It's just the level of difficulty relative to the cost. And the AR-15 is a classic example of where mass manufacturing has shown that you can make great guns for relatively low cost.
And the economy of scale doesn't hurt.
No, that's true. I mean,
the fact that you're making a gazillion of the things, if you were to take if you were going to try and get the sub-MOA AR-18, that's going to be a lot more expensive than an AR-15 because you've got to do all that work for the first time. Where on the AR-15, all of your development costs for that stuff all you have to do is just hit the button and spit another bolt out. I'm simplifying just.
Refer back to Hill and Mac's videos on how it's not simple.
My point being, once you've done the work, next gun is relatively cheap.
It's the same cutter did the exact same path on the same machine. Away you go.
Right.
Yep.
So the fact
Go ahead.
Which is from its basic design well suited to accuracy. Plus, we've been building them for 60 plus years now, plus all of the modern improvements to manufacturing production equals you can get a really cheap, really accurate AR-15.
Yep, exactly.
And this plays into the AK is a very popular gun on the American market as well, but it's not manufactured to the mass numbers that the AR-15 is, or in the iterative guises that the AR-15 is. I mean, you can get an AR-15 that's a low-end cheap battle rifle. You can get a precision SR-25 replica. Across the board, there's all these different AR-15 type builds and parts, and as a result, that mass market has developed in a way that even the AK has not. And so I know you could, this would push Jim Fuller's buttons because I've talked to him about it. The AK is capable of a lot more than the AK is believed to be able to do in the American market because the manufacturing and the quality hasn't typically been there to take advantage of that. Now, he's doing some of that, but he's one guy in a market that's filled with AR-15. And if the AK market was as big in the American industry as the AR-15 industry is, I think we'd see some really interesting stuff going on there too for the same reasons.
That's exactly it. And Jim, Rifle Dynamics, and the rest of that crew are taking the American side and applying those same techniques to the AK-47. So it's going to be really fun from where Faxon sits to watch where the AK can develop into.
So. Yeah, absolutely. All right, what do you got, Carl?
Next question. So what is the difference between a true match and a sub-MOA barrel? So, I mean, a sub-MOA barrel is just a regular barrel that happens to be able to perform at that sub-MOA performance level. But then there's a match barrel, which is a different title in the industry. You're like, I'm going to go buy a match barrel from Wylde or whatever, or Faxon. And so what's the difference there? Why do those why does that terminology even exist?
Marketing. So each company uses the term match a little bit differently. It used to be that match referred to almost exclusively to CMP. I mean, that was the game in town when it came to high-power rifle shooting, whether bolt-action or AR-15. So that really
marksmanship program for anyone who doesn't know that.
Yep. Awesome program. I hope more people are able to continue to get involved in that. So that was kind of the level where somebody said, okay, I've got a barrel that can be competitive in those matches. So that was kind of the unofficial standard. Now that's kind of expanded from there on out as companies have looked to set themselves apart on that. So, for example, you'll see Faxon will have a match series of barrel here in the reasonable near future. We've done that because we're confident that these barrels are highly competitive in a match environment. For us, we're defining that kind of as 3-gun on the semi-auto world, whereas in the bolt-action world, match is probably going to refer to hand lap, polished crown, polished chamber, near mechanical perfection in creating the barrel itself. So it'd definitely be up to the consumer to understand when somebody says match, what are they referring to? What standards and what processes are they doing in the barrel? Just kind of like we've talked about here, which will help them make their buying decision as they go forward.
It seems like the standards on everything have risen across the board. And
yes.
What is today, or what would be considered a match barrel 20 years ago, is kind of your standard off-the-shelf barrel today.
Getting pretty close to, yes. And what's considered match today in some of these bolt guns are, less than 0.2 minute of angle capable with reloads. So you're continuing to push the envelope more and more and more every day.
We eventually need to get a bullet manufacturer to do a video like this because the projectiles are so pertinent to that conversation. When you start talking about that level of precision, the projectile is really important, obviously.
Yep.
And I think we touched on this, the definition of match has changed over time. In 1903, when the national matches were formed, that's what became a match, right? And so when you look at 1910, 1920, 1930, there was no 3-gun. That didn't exist until the 80s. And so the idea of match then was like, an M1 Garand that had been properly bedded with a specific type of barrel with super precision sights, or a 1903 with some sort of precision sights that had done this or that or this. And so a match gun from 1935 was almost built specifically for the national matches, which became the CMP. But match today could be national matches, it could be 3-gun, it could be a whole, it could be Benchrest, it could be a whole wide scope of things when you say match.
Yep, that's exactly. And it's interesting, you look at how accurate were those guns in the 1930s, 1940s. They were having a hard time chasing minute of angle. Just by the nature of the precision, the barrels were really good. We'll say that. The barrel technology for the absolute high-end hand-lap precision barrels has not changed as rapidly as the production level of barrels and the technology and the consistency that's gone in that way, because those techniques were honestly perfected, a lot of them in the late 1930s, early 1940s with single-point cut, hand-lapping, etc. So what you're paying for is human time, because there's truly been no mechanical replacement for those processes. But the projectiles, just like you were talking about, the consistency of the swaging machines, the ability to actually measure each projectile was very, very difficult in those days without the lasers that exist today, without the electromagnetic scanners that exist today. All of those things go into the consistency of the projectile, which is so critically important.
Now, this isn't meant to be a lesson on the history of the national matches, but what's happened, and this correlates with what you're saying, over time, the guns have become so more increasingly accurate that the national matches have changed as a result. The targets from 1903 versus the targets in World War II versus the targets being used today have become increasingly more difficult to shoot a good score on because the guns have become increasingly more accurate. In fact, the AR-15, when it really started becoming a service rifle in the national matches, they started seeing guys turning in clean scores, which was impossible to conceive of. This was impossible. The idea that you could clean a national match was not reality, and now it became a reality, and so the targets have to become more and more stringent to make that course of fire more difficult in alignment with the guns that now can deliver scores like that.
Combine that with now what the matches are allowing magnified optics on service rifle. They're going to continue getting better and better as just the human eye couldn't keep up with the precision that was necessary for those ranges.
Yeah, you can't really have a serious national level competition and then have 3 guys all tie for first place.
No, but I mean,
Right,
literally, the scores that were being turned out with ARs at one point, people are like, how is this possible? This course of fire doesn't allow this to occur, but it's the targets have to become more difficult as a result. And like you said, they're now bringing in optics. That's going to change the game to a degree, although iron sights on that course of fire really do work very well. But because of the rifles changing and getting more and more quality over time with better barrels and better manufacturing and better capabilities, if you were to take you took the 1903 target and used a stock bottom of the line, I'm telling you, I guarantee this, a $400 AR could clean that course of fire based on what it was in 1903 because the rifles have changed that much.
Mm-hmm. Exactly.
Yeah, interesting. It's neat to watch the two correlate like that. Same line.
Yeah.
All right, let's go to the next question. What is the difference between lapping and honing? And I have to admit, I'm not even quite sure myself, so I'm kind of curious about this one.
Ooh, okay. So both are fundamentally polishing processes. It's just referring to the difference in how that process is typically done. So honing, let me step back for a second. When you make a barrel, you have drill, you've got a gun drill, a piece of bar stock. You're typically going to ream it in some form. Now, in some cases, that's mechanical reamer, so a spinning cutting bit. In other cases, it's electro polishing with some of the cold hammer forging guys. Everybody kind of does it a little bit different depending on their manufacturing process. And then you're going to have the option of a hone prior to rifle. So honing is basically taking the inside of a gun-drilled and reamed barrel and polishing it to mechanical perfection, to the maximum extent possible. So that is usually done using kind of a radial sanding bit, very, very similar, where it's passing back and forth through that piece of steel, just taking out the machine marks and taking you to the perfect size and the perfect surface finish. Honing's a really big deal for broach, single point cut, and some of the cold hammer forging processes. Because remember, in single point cut, you're never actually going to touch the bore again in that spot. You're just going to remove material from another point in that barrel. So that's your last time to really touch that surface inside that piece of steel. That way you can get the best finish and best consistency possible for honing. Button rifling is a little bit different. I can't go into that. Some that's more competitive secrets, but we don't necessarily have to hone, or we do it differently when we're doing the really high-end barrels. So lapping is literally taking a lead lap. Typically, it's done by hand. There's some mechanical processes now, but we'd argue that you want something done by hand. But the basic idea is I'm going to pour lead into the barrel and attach it to a cleaning rod or some kind of tool that I can pass back and forth through the barrel. I pull it out, and then I'm going to then attach grit of some kind. So it can be aluminum oxide, it can be all these different materials, and I am going to polish an already rifled barrel. I'm going to pull out that last bit of machine marks, and again, the same kind of objective as honing. I'm trying to get that perfect consistency inside that bore all the way from the chamber to the muzzle. Following me so far? So honing is usually done in one or two steps. Lapping is done in multiple steps because you're going to take a rough grit, a medium grit, a fine grit, a very fine grit, and then typically a final polish for those who are really looking for the perfection inside the bore.
Now, we touched on this a little bit in one of the other episodes, and this reminded me of that. So I brought this up before. David Tubbs' final finish were literally lapping bullets. They were bullets that were coated with some sort of grinding compound, and you would fire them in progressive order through your barrel. And the idea was you would accelerate the wear and tear on the barrel to fire lap any imperfections out of the barrel. So this is when you get a brand new barrel, unless it's been truly lapped to the point where it's perfect, which is unlikely. Firing the gun over time, even just regular projectiles, will eventually lap some of that out of that, and the actual barrel will become more accurate over time, or more consistently accurate, I should say, as some of those burrs or imperfections get worn out of the barrel, until, of course, it gets worn out to the point where it's now worn out. But that's kind of what you're talking about here.
That's exactly it. And we don't, as a company, recommend fire lapping in any way, shape, or form, except for certain old military surplus guns where the barrels were just that bad, and fire lapping can have a benefit to helping break in a lot of those old manufacturing techniques and get a little bit more consistent barrel. But I'd say something that's nitrided, what you're doing when you're lapping an already nitrided barrel is you're pulling out the nitrided layer of steel. Same with a chrome line barrel, you're pulling out the chrome. You're reducing the life of that barrel significantly very quickly.
Now, wait a minute. Are you saying that my 9130 that was $100 is not a better sniper rifle than an AR-15?
No comment. I mean, they both can be.
No, that Mosin will not. Sorry.
So this is going a little off, not off topic, but you just kind of said something that made me clue into something we talked about before about nitriding and that hardening of that surface of the barrel. If you want your barrel to be lapped to the highest precision possible, you would need to do that before you nitride it, right?
That is correct. So if you're looking to get the longevity of nitride on a lapped barrel, you're actually going to want to lap, as we talked about, for those doing the uber precision, break in your throat because of the difference in the reaming direction versus the tool marks and everything else. And then you would actually want to send it out to nitrocarburization.
Because if you wanted to lap a nitrided barrel, all you're doing is wearing out the barrel faster, and you're lapping out your nitrided process, and you're just wearing the barrel out, essentially.
Yep, that's exactly it.
Yeah, the nitride's going to lock in whatever the current state is.
Until you've shot it enough that you've worn it out and then you've done damage. You've actually not made things better. You've just decreased the lifespan of the barrel.
Mm-hmm.
Okay, cool. When I did the... I'm not going to mention torque wrenches ever again, so we're not talking about torque wrenches. But when I did the video putting together your free float tube and installing the barrel and all that, I mentioned that you want to make sure that the barrel's headspaced to your bolt, and that you should either buy the barrel with a bolt, or if you're using your own bolt, do a headspace check yourself. And I kind of just assumed that people knew what that meant, and a lot of people did, of course. But it inspired lots of questions. What is headspace? And actually, this could be a video, but let's talk about it here. So what is it, and how do you check it?
Okay. So headspace depends, one, on the type of round, but it is fundamentally the total gap in the chamber from the breech face to a specific datum. So datum is an engineering term for this is a hard point that everything else is measured off of. So it's going to be that measurement from the breech face to the datum of a particular round, which typically is measuring the overall length of the round. What you're trying to do is you're trying to get a good seal in your chamber that your cartridge is going to, when it detonates, that brass is going to expand. You're going to have consistent force generated by the explosion, and you're not going to have any blow by or blow back past the round, or in the case of too tight of headspace, a rupture because there isn't enough space for that particular round to expand through the detonation process. So headspace, like on an AR-15 or AR-10, using your standard 5.56 or 308 cartridges is off of a magical datum that's actually in the middle of the shoulder of the round. It's not actually the front of the case. It's actually in the middle of that shoulder. It's an interesting point for somebody to ever go look up. Take a look at the SAMI specs, and you can see exactly where that datum is defined. And then you have rimmed rounds, which actually use the rim itself as the datum for checking headspace. So it can depend on the particular round and how it's doing. For example, pistol rounds don't have a shoulder in most cases, so you're actually using the front of the cartridge itself. So it depends on the specific cartridge, what that actual datum is. So to check it, you're almost always going to use precision gauges of some kind, and there's no other really effective way. Yep, that's exactly Headspace gauges for anybody looking at Carl's screen. Typically, you're going to have 3 gauges, although for uber match guys, you're going to have many, many more gauges. But what you're doing is you're putting the gauge into the barrel, and you are checking that the breech face is that appropriate distance from that datum, so that you're going to have a safe and contained detonation. In most cases, there's go, no-go, and what's called a field gauge that most people are familiar with. So what you're trying to do is, like on an AR-15, you want the gun to not close on a go gauge. I'm sorry, you want it to close on a go gauge. If it doesn't close, you're having a problem. You have too tight of headspace. You want it to not close on a no-go gauge. So you basically, by using those two gauges, are defining this is my allowable tolerance for what is considered the nominal headspace for the cartridge at the beginning of its particular life. And then you have the field gauge, which if your gun closes on that, it means you potentially have an unsafe firearm. Do not shoot it because you have too much gap between that breech face and your datum. So in the case of, say, an AR-15, what that would mean is if you had too much of a gap, that would mean that when that cartridge detonates and those gases are expanding behind the bullet, they're actually going to go around the cartridge itself, and they're going to blow back into your operating mechanism of the firearm. So you're not containing the 62,000 psi detonation. It's going somewhere where it shouldn't, and that's going to be back towards your face. So it's a really big deal, a really, really big deal that somebody should check headspace on any gun that they've got, unless the manufacturer advises otherwise, because they've done those checks and they could say definitively, I am comfortable with that detonation near your face.
It's basically what you're doing is checking the stacking manufacturing tolerances between the chamber and the bolt and whatever locking system the gun has. Because, if they're... Go ahead.
It's important to note, it's exactly that, Ian. And headspace will change over the life of your firearm. For example, in an AR-15, the back of your lugs and the back of the lugs on the extension will wear because you're abrading them against one another at thousands of psi of force when that bolt is unlocking. So they're going to basically sand one another a little bit as time goes on, as well as your chamber, because you're putting a big detonation, hot gases through it, is going to change over time. So what you're really doing is you're checking headspace at the beginning of the life of the firearm. You're not necessarily concerned about it through the end of life of the firearm as much, because manufacturers have built in those tolerances to allow, okay, if it passes go, I know by the time that barrel's shot out, I'm not going to be violating headspace. So that's why we always tell somebody you want to be in that go range when you first get a barrel, because then I know you're going to pass through no-go and you'll get close to field, but your barrel is going to be safe through its anticipated lifespan.
Outside of the AR-15 realm, this is also of particular importance with surplus military firearms, especially ones with mismatched bolts. You can usually believe that a manufacturer will have checked headspace. A gun won't have passed military acceptance trials if it wasn't properly headspaced. However, because what we're talking about is stacked manufacturing tolerances, if the original bolt's gone and someone's just put in some random other bolt of the same model, it may or may not actually headspace. So before you're shooting something surplus, it really behooves you to check it.
And that goes back to an AR-15 too. When you replace your barrel, replace your bolt, because your bolt has seen wear. And it's not that necessarily manufacturers are concerned that that bolt is going to crack, although the likelihood after repeated impacts increases dramatically. What we're concerned about is that the headspace is out when you take your old bolt from on a gun that's been shot out and you put it into a brand new barrel, especially if you don't check it.
Right.
So
you've had the same amount of wear on the bolt as you have on the barrel.
Mm-hmm.
This becomes very pertinent in fully automatic weapons. You know, belt feds or whatever, headspace can get out of spec very quickly because of the high rate of fire and the heat generated and all the pressures that are going on in that kind of a gun. Generally speaking, I have found with an AR-15, especially semi-automatic civilian ones, once you've checked headspace, it's a very rare circumstance in which someone will shoot enough ammunition to shoot the gun out of headspace unless they're changing a barrel. So once you check it once, unless you're crazy with the gun, the chances of having to check it again is pretty low unless you change something.
And that's it. If you change it, check it. It's a $60 set of gauges from Brownells or any other major manufacturer. We tell people make sure you pick a quality company because there is some variance between the gauge manufacturers, although they're generally speaking pretty good. So
I go with Forester dies, and the ones I'm showing you here are for 8mm Mauser because I do have a little small collection of 8 Mauser bolt guns. And as Ian said, now personally myself, I have only seen one AR-15 I think ever not go into headspace, so it's a rare circumstance with modern guns. It can happen and you need to check it. But when you're dealing with Mausers or especially Russian captures or whatever, the bolts have been changed, things have gone on, the gun's been shot a lot, someone didn't clean it. And so generally speaking, you check with the go almost always goes. The no-go frequently goes, but it doesn't close on field, and then at least you're safe enough to fire the gun. But if an old milsurp gun or any gun closes on field, don't be shooting that. You need to look into it.
Yeah.
Yep. And there's a little tidbit to everybody else out there. There is a difference between 223 Remington and 556 NATO gauges. All right. The 556 NATO gauges, being for military spec, allow more tolerance or allow a larger headspace to pass each individual gauge. So as a civilian shooter, generally we tell somebody, even if you're buying a 556 NATO chambered gun, since the datum in that shoulder is the same between 223 Remington and NATO, use a 223 Remington set of gauges. That's going to give you more warning than using a set of 556 NATO gauges.
That makes sense.
And funny, that goes right back to our first question about what are these different chambers, because that plays right into this.
Yeah.
Chamber's not different. It's just the military specification for the gauges. In the case of field gauges, 6 or 7 thousandths longer for a military weapon than the 223 Remington allows. But you're still going to be safe. If you've got a 556 NATO chamber and it passes a 556 NATO field gauge, you're still safe to shoot that particular weapon. But if you're buying something new off the rack and you want to make sure you're perfect as you just get that gun, then the Remingtons are a little bit better.
Because as you said a moment ago, the datum point for headspace check on a 556 chamber isn't different between a 223 and a 556. That's the lead we're talking about in the throat. So with a headspace gauge, you're just going with a slightly larger, thus safer tolerances and clearances with a 223 headspace gauge set versus a 556.
Yep.
And this is going way off topic, but it's cool, so I'm going to say it anyway. If you've got one of those belt feds, high volume of fire guns, often it will have adjustable headspace. The Browning 1919, for example, one of the key elements in learning how to use them is learning how to set the headspace, because it is very easily adjustable. And that's... If you see, by the way, if you see someone setting up at like a machine gun shoot with an M2 or a 1919 and they don't check their headspace, stay away from that gun, because that's the sort of gun that explodes and hurts people.
Even to this day, the U.S. military still has to check headspace on every one of its MODUSs that are in the field. Mm-hmm. We're just trained to do that. And that's just due to that is a very high pressure, very long exposure to gas, the flame jet of the round. 50 BMG is just bigger, so you have to worry about it more often than you do, say, on a SAW or an M60.
And every time you take the barrel off and put it back on, you're resetting headspace. And
in iterations over time. That's the general. I mean, that's the SOP of a MODUS. You need to check that regularly, and you need to make sure the gun's within spec. And in fact, there's pictures on the net of this has happened more than once, of course, where it wasn't done properly, and these things do let loose on guys shooting them, and it's a bad day. So unless you check headspace on one of those guns, like you said, Ian, at a shoot, or even militarily speaking, stay away from that thing, because it could be potentially very dangerous.
Yeah, if you have gas blow around the cartridge, or really bad case, when you think about it, really, really long headspace means you actually have a gap between the bolt face and the back of the barrel, which means you have a little portion of brass case in there that's not actually supported by the chamber. And a really bad case of long headspace, the brass will rupture while the gun's in battery, and it will blow out, and that does really nasty things.
And most people will, if they've ever shot an AR-15 where you see the bottom of the bolt blow out, and this is where you go into Sullivan and the rest of his team figured out how to contain a catastrophic detonation by purposefully building in a weak point into the bottom of the bolt carrier group, so that when it ruptures down, blows the magazine out, etc. That's usually a sign of an overpressure inside your barrel, which is either obstruction or often headspace. Or bad ammunition.
Yeah.
Your headspace is perfect. The ammunition wasn't. Sorry.
Yeah.
And you touched on this, Ian, but like every gun has a different way to mitigate a problem if it's out of headspace. You can replace a barrel. You could, for example, with a Kar 98 or Mauser, you could just change bolts, maybe until you find one that happens to be in spec. All right, so where I was saying is that the way you fix a headspace problem on a gun depends on the gun, right? So like with a Mauser 98, you may have to change the barrel if it's too far out of a headspace, but just changing bolts, if you have extra bolts, you could actually find one that fits. On an AR-15, typically you can change bolts until you get the right combination, or change barrels again, or both. For example, a G3, you can actually put in plus-size rollers. The rollers can actually fix the headspace on a gun. Don't do what SEPMI did and actually grind off the front of the bolt carrier group. That's not the right solution. They did do that on some of their early builds, and that's a bad idea. But so yeah, they really did. And so yeah, that's a whole other story. But there's ways to fix headspace on guns that are out of headspace. The worst case scenario being changing the barrel, but doesn't mean all is lost if you come across a gun that doesn't headspace. Sometimes there's easier ways to fix it depending on the gun you're dealing with.
And, this is an interesting throwback to what we were just talking about manufacturing techniques. If you look at, for example, the FAL, the way those are put together, they have a removable locking shoulder. So the part that the bolt is actually locking against is a removable piece, and they made multiple different sizes of them. And so if you're building a FAL parts kit, you get a couple of locking shoulders, and you just test them. And what you're doing is accommodating stacked tolerances. So if your barrel's a little short and your bolt's a little short, well, you need your locking shoulder to be a little bit longer to compensate. And that's just how those are manufactured.
Yeah, same exact thing with the delayed roller stuff. You can put in minus size rollers, same, or plus rollers, and the same thing until you find that right number.
A lot of people will probably recognize Enfield SMLE bolt heads. They made multiple bolt heads for exactly this issue. If you're out of headspace, well, you put on the next longer size of bolt head until you're back in spec. I'm sorry.
Yep.
And just if a barrel's worn out to the point that the headspace is currently outside of safe spec, doesn't mean the barrel's worthless. You can actually, for example, with an Enfield, might change that bolt head until you get within safe spec again, and it may still pass acceptable accuracy standards even in that situation. It doesn't mean it's done. It just means it's getting there.
Right, because acceptable accuracy is like 4 minutes of angle.
Which, at the time, that made sense.
Sure.
Yeah, totally. Hopefully
All right,
that helped people out. Go ahead.
What's up next?
All right, the next one. This one's actually probably a long one, I think. Maybe not. Thermal dissipation, weight versus function. And before we go there, we're going to be doing something about this, because what we're doing with the What Would Stoner Do rifle builds, we're going with the pencil builds, and we're going for very thin barrels with the nitriding process and believing in having faith in modern manufacturing. However, like for example, when you look at the IAR or the M27 or the HK416, they went the other way. They made this barrel that's like this big around and a gun that weighs 10 pounds because they're trying to achieve a different goal. And we actually have a video coming out a ways from now. We're going to talk about those differences. They're essentially the same problem addressed in a different way. But let's go ahead and go there. Thermal dissipation, weight versus function.
Okay. So cold bore, we've talked about this in the other episodes, you're not going to see a significant accuracy difference between a heavy barrel and a light barrel. All right. When the steel's in its natural state and it's in its normal temperatures, you're not seeing anything too particularly crazy. You do see some differences just by the base rigidity of the part, but that's minor relative to the condition of the bore. I mean, for example, you guys have shot your guys' thin barrels, and I understand you guys have been very, very happy with it. Thin barrels are very capable, more capable than people give them credit for. So the role of adding material to a barrel is to be able to offset heat. That's the big one. The more steel you have, the more heat that you're able to absorb without having a significant change to the base rigidity. Or when it's really, really hot, you have enough material to offset the change in the rigidity of the steel itself. So think of it in the same way that if you have one stick, it breaks easy, but you get a bundle of sticks, it doesn't break very well at all. It's kind of the same analogy. The more material you have, the bigger the bundle of sticks in terms of handling that particular barrel. The second component to that is the overall surface area of the particular piece of steel. Thin barrels, they don't have much material to soak up heat, and then they have commensurately less surface area to exhaust heat from the outside of the barrel itself, where the steel to air barrier. So what you're looking at, like with the M27, is they're saying, hey, I'm going to be fully automatic. I know that. Therefore, I want a lot of material to be able to handle the heat, to maintain that accuracy, and I want the high surface area to exhaust the heat faster under those circumstances. That's a big one.
That's a 1919 barrel. Air-cooled, exactly what you're talking about. But if you have some other mechanism for cooling the gun down, that's a Vickers barrel.
Yep. So they're
indefinitely, despite being way, way thinner, because this thing's surrounded by a water jacket.
Yeah, and it's based on what your goals and purposes are. Like we brought up a little earlier, well, we brought up maybe during one of our chats. If you're the M16, the M4 wasn't built for a very long, sustained high rate of fire. It was meant for brief interactions, a lower rate of fire, not meant to dump 600 rounds. And so the pencil barrel if your goal is to not have an incredibly long sustained rate of fire, pencil barrels, and especially modern ones, as we're going to have other videos about to prove that, really are incredibly effective, and you have this great weight mitigation and the ability to do almost everything you'd ever want to do with that gun, keeping its original goals in mind. If you want to turn a pencil barrel into a squad automatic weapon, you've kind of gone down the wrong path.
Like the BAR.
I mean, you absolutely can take a direct impingement gun, and it can be a squad automatic weapon, but you're going to a fat barrel really quickly. And if you look at when the IAR competition came around, they go to other things like open bolt, so there's more circulation going through the system to help cool it down. Or you do other things like the Lewis gun or the Vickers guns and other things, and you take forced induction of another medium to help cool the part down.
Yeah. I would say the BAR and the Shosha are excellent examples of all of these concepts. They're both guns that were deliberately designed. They compromised the sustained fire capability in exchange for being lighter and mechanically simpler. And when the BAR got pressed into service as a support weapon, as a light machine gun, just like the AR-15 does, it overheated and you destroyed the guns. That's part of the reason the Shosha had the same sort of negative, or part of its negative reputation is it had a thin barrel. Now, it actually had an aluminum radiator shroud inside there, but not very big. And the barrel itself was a rifle barrel. Actually, they were Lebel barrels, so a very thin, lightweight barrel. And you had about 200 to 300 rounds of sustained continuous fire before the thing overheated.
Yep. It's just the design parameters of what you're putting the weapon for. The M16 was not designed to be a squad automatic weapon. I mean, note, Stoner and the rest of them did 20-round magazines. 30 rounds is a huge difference in terms of the heat that's generated inside the gun. Now, it's a boon for all of our infantrymen, and as a former Marine, I appreciated having extra ammunition. But it does go into you're trading things off as you pick up capacity or you try to pick up full automatic rates of fire on those weapon systems. I mean, the Marine Corps had 3-round bursts. Everyone said it was to conserve ammunition. Yeah, it was part of it. It was also to keep the heat of the weapon system down, because when you got into ambushes, they went full auto and they started blowing up guns, which was unfortunate.
That's interesting. I never thought about that. Yeah.
There's always a lot of reasons for it. Now,
sure.
Yeah. Anyways, we can get into another conversation on that.
This is where you can get into a controversial place, and it's a conversation I've had with some other groups as well, in which the idea of, and I'm not saying there shouldn't be full auto on military weapons, however, it is a common situation, and we've seen this at least with even not recent, but modern history, military history, in which sometimes that full auto switch is engaged in times when it shouldn't be, and dumping mag after mag after mag just because you have the capability on the weapon doesn't mean you have the capability on the weapon. It has a switch to do that, but the gun can't keep up with it. And so this is where sometimes having the ability to switch to that option and dumping those mags may have actually been counterproductive to the goals of sustaining the ability to keep off ISIS or whatever from your FOB, your FOB. If you had stuck to semi-auto, maybe your guns wouldn't have overheated and you could have laid down similar or not as high rates of fire, but still been in the fight when your gun in full auto blew up.
It just goes down to the design philosophy was, and I can tell you as I was a Marine, so every Marine's a rifleman. I technically wasn't infantry, but I wanted full auto. You do want it for, oh crap, I'm in an ambush, I need to gain fire superiority. But it's not designed for, hey, I'm going to dump all 270 rounds on me. That makes you combat ineffective.
Well, it can easily become a panic switch when it's not supposed to be. And I'm not denigrating anyone. I understand that. And I think I could fall into the same paradigm. But when that switch becomes panic switch, you're now overreaching the capabilities of the weapon you're using, and you could blow the gun up or whatever. You know, Ian, the Falklands War, guys, everyone wanted to pick up the full auto gun, and the reality is it wasn't better.
Right. Yeah. The Argentinians had select fire fouls, and the British had semi-auto fouls.
And as I understand it, they were picking them up when they could, but it turned out that if you look back at memoirs, they weren't better to have. It just everyone wanted it.
Yeah. Yep.
All right.
Let's talk about fitting extensions to receivers and what the effect is on accuracy in doing so.
I'm sorry, I laugh because I've been customer service, in fact, and so fielded this question many, many, many times. So people tend to believe that there needs to be an interference fit between the AR-15 extension and the front of a receiver for you to get maximum uber accuracy out of an AR-15, and that if it doesn't interference fit, especially when you're between multiple companies' parts, that you have lemons, that something is wrong with that particular weapon system. That is so far from the case, it's not even funny. Or I guess it was funny. The vast majority of the accuracy out of the AR-15 comes from the interface of the flange on the AR-15 extension and the front of the receiver itself. You're worried about the surface area for the forces to run through during the ignition process, because the actual recoil is going through the extension, through the flange, into the receiver, and back into the weapon system. So you want the most amount of support possible there. That's why you always see receiver lapping kits and other things, is you're trying to create a truly square and solid face for your extension to seat against. That's what you're primarily looking for. You're not necessarily looking for that little extra bit of support of the extension being press fit into the receiver itself. It can help, yes, but you're going to get 99.7% of the accuracy by just a good flange to receiver fit up and a great barrel nut that squishes it all together and keeps everything square.
I like the highly technical term of squish, actually. I'm a big fan of that word, and I think squish is the right term.
I'm sorry, I could have said crush. Go back.
Smush? Smush works too. Yeah.
Oh, yeah, I like that one. Uh-huh.
This sounds like an area where we're going to get dangerously close to needing a torque wrench.
It's, if you're looking to support it, one of the easiest things to do is to take blue Loctite or something and coat the extension of itself. That's just kind of like bedding that you would in a traditional bolt action gun. But that's not going to be the big thing that's going to get you your accuracy. Appropriately free floating it, getting solid mating between the barrel nut to flange to the receiver, and having quality muzzle devices in the barrel is far more important than that receiver fit. And it's normal for there to be a little bit of wiggle on it before you put that barrel nut on.
I get that, and totally. And the reality is, if it was possible to do such a thing, a barrel floating in space with no upper receiver and a bolt carrier group that was locking that bolt into that barrel would be just as accurate, because the AR-15 is designed in a way that the upper receiver doesn't have a lot of play into how the gun works beyond making sure all the parts guide into one another, because the bolt's actually locking into the locking lugs, which is part of the barrel itself, not part of the receiver, unlike previous older gun designs like an Enfield or something like that.
Yep, that's exactly it.
Well, we have hit another hour again, actually, guys, with 7 questions. Do we have anything else we want to bring to this table today? Otherwise, we'll probably seal up this one for the next one.
I think nothing other than to say to all of the listeners and viewers, please send in more questions. Faxon loves doing this with Carl and Ian and the rest of the team. And, hey, if there's anything that we said that doesn't jive, ask questions. We'll be happy to explain our thinking, or, worst case scenario, refine it based off of that feedback. And we thank consumers for it.
I think that's a good point. This is a conversation, right? I mean, there's always an opportunity and chance to learn from any side of the table, whether it's your side, which is a professional manufacturer, our side, which are, the hopefully an educational channel, but there's always a chance to learn more, and sometimes the viewers bring stuff that we never thought of. So bring that stuff, bring the questions, bring your input. If there's something you disagree with, that's fine. Bring it in a courteous way. Show your work. That's an important part. Don't just say you're wrong. You're wrong because be courteous and talk about why. And that's a welcome conversation to be had on any topic on InRange, because we want to learn, and it's all a process where we work together to do that. So I'd like to thank Nathan again for joining us on this, and I'll give a little tease to people out there in YouTube land, or video land, I should say. We do have another video we're going to be working with you on, which probably isn't going to be about rifles. It's going to be about pistol stuff. So we have another project coming. So that's a little tease. We're not going to say more than that, but some stuff going on there, and that's probably going to be part 5, is going to be about pistols, which I think will be interesting in its own right.
Yeah, definitely.
So anyways, thank you again, Nathan. Thank you for the viewers. Guys, this is, again, a fully viewer-supported endeavor. We're not taking ad revenue from YouTube or anyone else, nor from Faxon for that matter. The reason InRange exists is because of the Patreon supporters that make InRange exist. So we thank you for that. If you're not part of that group already, please consider doing so. $1 a month gets you into our monthly raffles or whatever for gear that we give away, but if nothing else, it keeps InRangeTV alive. The other thing you can do is subscribe to all our channels, and more importantly than that, share the content that you find valuable to your friends anywhere, everywhere you can, because we need to rely on you, the viewers to bring this cool stuff to people who maybe don't know exists, or just to spread the knowledge. So once again, thank you for watching, and thank you for everybody involved.